Okay, so based on the accuracy of the answers, and I'm so sorry, my voice kind of low. And basically, what we have here was, the final exams. We have no final review, no final review. But remember, besides the office hour that we have on Thursday between 10 o'clock till like um 12 o'clock, um, so you want to welcome to stop by, or it can be on Zoom. I have a student on Zoom as well. I also have office hour on Saturday, let's say from 1 p.m. So we can always stop by on Zoom if you have any questions, because we do on Zoom. Office hour must be on Zoom as well. Um, so we can do on Zoom, and then if you have any questions regarding the final exams, I will definitely answer it. I will tell you the final exam. You just simply review like objective from objective one until objective like six or something, six, five or six. Okay. So don't go too far like to objective seven. It doesn't even cover you like the confident level. It just basically going to ask you like some very conceptual questions like what is the mean, what is standard deviation, what is final summary, what is uh like 68%, 95%, 99.7% from the empirical rules, or from the Shepard theorem. So all of this are very important. Yeah, I graded. For some reason, I got some stopped like by the students, and so for some reason, the grade wasn't enter. I would definitely complete them. I believe I almost finished grading it, except like like one or two or three people. Okay, so um. Anyway, so we do not have the final exam review. That's going to be very challenging. I'm a person who loves to have to give the student a final review before the test, but due to the time constraint, we don't really have much time left. So meaning that the final exam must be done. The final review, I will give out some additional hours, just making sure that we can participate on Zooms like on Saturday if you can. That's perfectly fine. I just want to go over some of the key concepts on the objective. Remember, it's the final exam is also taken from the objective questions, but it's not like a calculation based question. This will be a conceptual based question. So you don't have to be very concerned about like confidence levels or hypothesis testings, like how I'm gonna compute a Z or T score or a pair T test, something like that, which will not be on a final exam. The answer is no. So since the final exam is always be 100 point, and just like the normal exam, the extra credit part is basically from the attendance. Plus, the thing that we did, like handshake, I believe that most of you did on the handshake registration, and also 2% from the final data date, so final project. All right, the final project is must be done by um by the last day of class, of course, by Monday. I must be able to grade it like quickly. And then today I will be upload some makeup project, makeup data dates. Okay, must be done for those who want to get like 2% edge credits, and those who want to get like um A plus, or student an A who attempt an A or A plus, right? You must do the final project who attends. Uh, uh, okay, A plus or A plus. Okay. If you just want to get an A minus, you can still complete the final project. That's gonna give you another 2% edge credits. So it's gonna add you to the title, all of the data set points, like, and then 15, 20 of them. And then, just answer and then pull out the chart from JASP and all of this, right? It's just summary of what we have learned for the data day. So make sure you're gonna complete the final project by Monday, December 22nd. I must give out the grades by Monday. So um, if you cannot finish the final project, that's perfectly fine. But you must complete them by Monday. Uh, by the final exam is not by 11:59 p.m. The cover page can be done quickly. It's a require for the final project. If you don't have a cover page, basically you're gonna lose points. But it doesn't necessarily have to be like so perfect. You see what I'm saying? If you get about like 7 or 8, you will get that 2%, and then you should be able to get an A or A plus. If you attempt to get an A or A plus, it must satisfy certain requirements, but it doesn't necessarily have to be like too perfect. But I do have a student who just did it perfectly. But anyway, uh, you can't you can't just get your Word file and then open your school computer, just save, email yourself, open the school computer, and then, do the copy page. I'm not sure if that makes sense to you. Okay. You try the mobile Word file, and then it doesn't. Okay. Uh, anyway, y you can try the school computer, and then it will definitely gonna work for the final project. And also the data day four. The data day four just helps you do the regression models, and I can shoot you the instruction quickly, but usually it's not matter that much because we learn how to find the regression models like on Jazz. You just like few click. It's more likely to be on the explanation parts. Okay. All right. So I just talked too much about the things that I will. I'm not sure we have enough time to talk about this next week, because next week gonna have exam four and data day four. And then that's it. And then we don't even have like a final exam review. So I'm planning out to give out some office hours on Saturday or Thursday. Like, it's not mandatory, but it's good that people gonna, like, get inside, get on Zoom, and then I'll let you know and give you some kind of information about a final exam. All right, so objective A, continue. All right, I just want to remind you that the objective eight, um, there's no extension for these assignments. Yeah, it is only one objective, but I know it's going to be a lot of work, but we went over every question. Um, yeah, so the final exam is on the last day of class, which is on Monday, December 22nd. And the final knowledge check, I will let you the date. You should be complete them by a certain day on Saturday or Sunday, whatever the time. We do have the practice final exam. It will be 50 question and we're gonna make that available, but it's not gonna count toward your grades. The Objective A extension is simply due on 10. Oh, I think we're gonna have the exams on 12 or something. I'm so sorry. Um let me just double check the schedule quickly. I forgot. Yeah, I'm so sorry. Next Tuesday gonna be data day 4, and then the Friday is gonna be objective 4. You still have a lot of times to complete them. I do apologize for that. Uh, I just messed up these two. You have to do the data day first before the exams. Okay. And I'm gonna give you some information on the exams next Tuesday. Besides the data day you have to complete. I'm so sorry. So this is data day 4, and the exam should be on Friday. So remember that the data day must be due like 2 days before the exam. So it's very important that um we complete them by Wednesday, December 10th. So no extensions. Just making sure. Yeah. I'm so sorry. So the exam 4 is on it's on Friday. It's not. Okay. So this is going to be the last day of class as well, and before the final exams. uh, Before the final. All right. So let me continue on it. I just talked too much about the uh about the deadline. So let me double check that's what we have so far. Yeah. So this one just simply asking us about the degree of freedom. So I think I posted on MySpace regarding the course material that we have so far. Yeah, so yeah, I actually put a little information about the slope, and then the one the Seth. I think is one of the thing that we the degree of freedom of the sum of a square is n minus 2. Yeah, and the same thing for that we have 90 years worth of this. Yeah. So double check. Yeah, we just add them up like six of them, and and that one was 83 and 89. We subtract from that. It's the total sum of square. Always be the total of the degree of freedom, so n minus 1. So yeah, this is not a big deal. I'm focused on the mathematical competition for that. is 89, and this one just 6. Uh, the number of the number of multiple regression models, number of multiple variables, and then this one just taking 89 minus 6 is 83. They always have to add up to 89 total degree of freedom. So the 89 degree of freedom based on the total sum of the square, and then just n minus 1, we have 29 in this case. And then we're gonna get x1, x2, x3, x4, x5, x6. So we're gonna take 90 minus 1 is 89, so we can't just compute that along the way. I don't think that's a big deal. So I'm focusing more about the out of sight test or so on and so forth. The median test is might be a little bit more tricky part, so let me just go through that quickly. I think we did this question before, but this question will be on the exam, just making sure we get this right. Okay, so what the question asking is like everything was fixed, right? And then we only the average change. Remember, this one worked for the X bar. X bar always be the unbiased estimator for the regression models in statistics. So we always work with the average change, which is the mean. So let me double check that. So I want to see how much Y gonna change if uh we have like additional might that the truck is driven. So we need to identify the X that it's gonna change in terms of the slope. So so it's basically work for the X4 in terms of the miles, right? So that's X4. It's change. Yeah, some question like that, we also have a high chance to see on a final exam. I know it's somehow it doesn't cover objective A, but there will be some portion of it. It's going to be like these kind of questions. We have multi regressions, x1, x2, x3, x4. And then so if everything is a state constant, if uh the rest of the variable got fixed, and then one of them being changes happen to the y predicted y values. So when x4 is changed, meaning that it's gonna affect by the slope. So we look at the slope, right, of the regressions. So we simply state how much is gonna change. So for every time that x go up by 1, x4 go up by 1, the y is gonna go up by 0.03, right? Apparently it's go up by a factor of the slope. And then it's have to be increased because that is the positive slope. It basically means the positive correlation. Um, as simple as that. Uh, you can, yeah, it's not gonna be something really complicated. Okay, I'm trying to find the ANOVA test was something I did not post. Yeah, I think they actually change um the system a little bit. Um, Hold on, just let me double check that real quick, okay? Uh, I need to post the material regarding to the ANOVA test, which I did not do um from objective. So yeah, I actually did it like but not in this class, but basically from like a stat 213 when we talk a little bit about the ANOVA test. One of the application is one to test on the multi uh means from different populations within group and between groups. So I did not really uh post about the application on the app test. So this is how that we're gonna look at the group that being studied. We have the two groups, and you can literally gonna use either the paired t-test or independent t-test, or we can also treat it as one way and over if you have more than three or more, something like that. Um, so we can have the one-way repeated measure and over and independent sample and over. So, but I don't think that's it's gonna talk too much about this. And we want to compare about the variance. So we basically have the sample mean. We want to test on, hey, if the variations of those averages within version A, B, C, and D matters. Um, So we can actually compute. Yeah, this is how I create the hypothesis, which is not required for our class, and this is what we have to compute: the sum of squares, the mean square, and then we can compute the app test based on the mean square over MSE. So we can also compute the degree of freedom up for error, that which is what we did earlier, and the degree of freedom for the total number of the observation, which is the total sum of square, and that add up to the total of the sample minus one. And then the degree of freedom is based on the number of groups that we're gonna have as well. So we're gonna have like we got two tests on four different means. So that would be K will be four minus one. You have to look at three degree of freedom because we want to test on four different average. And then we can also compute the sample standard deviations along the ways. And then so on and so forth, we can compute the sample mean within the group. So we need to make sure, let's say we have sample mean for 157.8 among 79 people, 153.6 among 79, and then we need to compute the average for all of this. So since they have the same sample size, so this one relatively easy, just add them up, divided by four. And then, yeah, this is what we have to do with this. And then finally, we're going to compare the app test. If the app test was significant, for example, was bigger than by a certain design number by of the significant level, so that we're going to say that it matters, right? There'll be at least two means that they have like different value when the p-value is relatively small, of course. So yeah, this is how they compute it, and it's gonna take a while to get it done in this case. But in that example was kind of simple um because they have the same size, the same sample size, so you don't necessarily have to do like M1 minus 1 times S1 square, and 2 minus 1 times S2 square, and K minus 1 times SK square. Um anyway, so all we have to do just um yeah, the app test was kind of was kind of tricky for stat 113 because we sort of having no understanding of like comparing like two sample instead of like three or more sample. I did not really have enough time to explain it to us about like two sample uh Z test and T test. And now I have to deal with like um multi-average, multi-mean comparisons. So it might be a little bit tricky that we need to perform a little bit math. We just simply take um 79 times 10.176, which is 803. And then on 9, and then you can have the mean error, which is the mean for the variance. The sum of averages, add them up, divided by 4. Um, because they have the same thing, so you don't have to do like n minus 1 times this one square or something like that. This is what I did on a note, so it's kind of different. Okay. Yeah, this is how they explain it because they don't um the the Alex doesn't do what it did on the notes. We're sort of thinking, well, we're just taking um the estimations of the population variance divided by n, so that's gonna give us the variance of the sample means. Because we have learning from chapter 7, which is on objective 5, that we can also compute the sample average of the mean by obtaining this formulas, does the standard deviation over radical n. So that's gonna be the same concept. So we call this one as a pool variance. But for my case, that we when we compute the SSE, so since we have different like sample size, so we have to compute it that way. Okay. And then we have to divide it by the total number of this. In this situation, you don't have to because they have the same number of people. Okay. So I believe that most of these questions will be giving us with the same sample size. So that's gonna help us doing it so much faster. Um, we can always try it out with like we just simply add them up divided by 4. You're gonna get the standard deviation. So so if you see this question on the exam, so we just send you just have to send this to the calculator for examples, and then just take the average. Okay, take the average. So make sure we're not gonna compute it by hand because the calculator already give us the mean and standard deviation. So we don't add them up divided by 4. We just simply send the data sets to the calculator and just hit on the X bar. So that's what we have for the average sample variance. Because they have like a same sample size, so we can all do that. But if each of them has different sample size. Let's say the version A got like 65, version B gonna get 60, and version C gonna get like 20, something like that. So we need to multiply by the corresponding standard deviations, and minus one times the standard deviation, add them up, divided by total. Um, so that's going to be kind of tricky. But since Alex only provided with the an example that give us the same sample size, can always compute it that way. So the answer for that was 451. And then you're gonna compute the average as well. For this part, we just simply look at we take the standard deviations, um, square over 77. We have to compute it normally, but the Alex system is sort of doing the estimation based on the means that we have was um the summing mean it was 1,463.7. So we're gonna take 451.7 and then we divide it by 77. It's gonna get something close to that. So um I know it's not gonna be perfect. If you really want to do the perfect parts, then we have to compute um the, the entire MSE, so that's kind of different from what we have. So, all right. In other word, we just simply take something that we have valve, and then we divide it by 77, which is the sample size. So we end up with 451.7 over um over n was 77. And then you should get something close to like so 451.7 over 77. We get something close to um hold on, this based on the sample mean was so hold on. Yeah, but essentially we're gonna get like the standard value for 77, about 19. Yeah, it's kind of tricky. I think I have to do it my way, so it's gonna be a little easier when you compute the F test and when you just divide it, you're gonna get the F. Um, Let me compute the sample standard deviation of, I'm gonna send that to the calculator. and then gonna compute the sample standard deviation among this. You get 4.35, right? And then you multiply with by 77. Yeah, you would get something very close to that. Very close to that. So yeah, so I'm gonna compute the all right. It's kind of hold on, yeah. Yeah, it should get something like close to 21 instead of that. So it's yeah, I'm trying to figure out like how the Alex system got to 19.0009, and then if we do the exact value, you have to follow the steps that we have over here to compute the variance. So, and then we can also compute it that way, but it's gonna take so much longer. So let me do 76 times 323.2 plus 76 times 578.2 plus 76 times 440.1 plus 76 times 465.3. And then we divide it by 76. Yeah, you're gonna get thousands. Hmm. We divide it by n minus 1. All right, so yeah, so it should be done quickly for the sample variance. And when you square it, it should be 19. Yeah, something like that. It should be something like that. When you square it. Yeah, you're gonna get 19, something like that. Yeah. So, ho- so you need to compute the sample standard deviations based on sample variance based on this, based on the Explorer. So, all we have to do is just simply use a calculator to get it done. So we're gonna send all of these uh, values to the calculator. So hold on, let me do that again. Just making sure. And then I'm gonna compute the sample standard deviation. And then after that, I'm gonna square them. So we're gonna get something like you have there's no way we can do the sample variance on a calculator, so we have to get like 4.35, 4.36. And then after that, we're going to um square that. Okay. Yeah, we can't really compute it like directly from the calculator. You have to square it again. And you're gonna get 19.009. All right. So after we compute a sample variance, is simply um we can literally check and how much difference. So we're gonna get the standard deviations based on 19.009 times 77. Yeah, we should be able to get to the final answers, which is about 1463.7. It doesn't matter what it, yeah. Yeah, so when we enter that, it should be able to give us the final. I think we have to keep a decimal point like 1463.7. Okay, so that's a kind of like tricky part. Okay, so for this kind of question, we just simply first step we have to find the average for the sample variance. So when you compute it, you're gonna get 451.7. After that, you need to find the average with the standard deviation among the sample means. So I'm gonna send it to the calculator as well. And then you're gonna find the standard deviation first, and then you're gonna square it, and then you multiply by n, which is 77. You're gonna get to the final answers. Okay. Yeah. So this is what I want to compute the sample standard deviation among the average among all of these data sets point. And and this one we want to compute the common population variance uh, or based on the sample variance. Okay, so that's the thing that we have to do. And then we don't necessarily have to do the app test. The app test we have to take the division. Just ignore that. All right. So yeah, and then yeah, so we don't necessarily have to compute the variation with between the sample and then the variation within the sample. So we don't necessarily have to compute it. The question going to give us the ANOVA app test based on the information that we have ready. So you want to find the p-values based on the app statistics. All we have to do, they have the app statistics right there, and um, so we're gonna compute it with um, what is the app statistics? So we got 4.33, and the degree of freedom that we got over here, we add them up, divide we add them up and minus 4. So we're gonna take, I have to add them up first. I'm gonna take 70 plus 147 plus 131 plus 51. We got 399 minus 4, 395, and then gonna get 3 sample, right? So we just simply based on um, the degree of freedom. So let me just do that again. You're gonna get like a 4.33, and it's kind of weird that we have for the app test for the ends over here. Let me just put down like 3 and then this one 399. Let's see if they come up with the results. So the result it says 0.0051. And then since the p-value was so small compared to 0.01, so we have to say yes. Okay. It's not something really challenging since we have a calculator, but a calculator is kind of confusing how we're going to compute the degree of freedom based on that. So you have to be extremely careful. Like one. Okay, so the way that we compute, let me just double check that again. So we're gonna take 4.33, and then this one's 4 degree of freedom. This one is 300. We have to add them up, and then no, this is three. Yeah. So p-value was equal to 0.0051 is less than um, what it says 1%. So you're gonna the claim is correct. Correct. Okay. Simple set. Wait. All right. So they basically give us like all informations. Um, and then for the ANOVA test, what is unbiased estimates? Common variance is based on the um between groups. And the p-value is just simply you have to find the app test by taking the ratio between groups and within groups, which is the error. And then after that, we're gonna compute a p-value based on that, you're gonna take 1086 over 426.3. You're gonna get 2.54, something like that. And then 2.55 actually. So we just have to round up a little bit, just take the ratio for that because it was given, so you don't necessarily have to compute it. And then its error bar was 426.3, and it's 220 samples. This is what the question says. Uh, we just this is the degree of freedom, and then we just add one, and you get a 220. The p-value can be computed by taking the 2.55, and degree of freedom is 4, and this one is to 19, you're gonna get something like close to like 0.04%. And they're gonna say yes, based on 1% level of significance, something like that. Yeah, it's not gonna be something really important. I need to really go to that side test. Yeah, and also we need to compute the order difference because this is what we do not have for the lectures because um so but I would definitely go for that if we like have enough time. You just read these things and then you just want to rearrange the data sets so to the calculators we compute that statistics and then the same thing with the 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 constant test, the rank test as well. Yeah, this one we have to um find that critical value. I'm definitely gonna send out some notes how we're gonna solve these two questions. Um, it the note that I sent out wasn't really good enough. Like I don't think people can uh, do this. We have to take the value, absolute value difference, rank the absolute values, difference, and place them, and then take the total sum of the positive ranks and negative ranks separately, and then compare to them statistical value, basically going to be on the smaller sums. So you have to perform all of these steps um, when we want to find the difference between um, the side rank test. I know I'm not gonna be able to do it. We have to do it by hand. I don't think we are able to send them on a calculator and take the absolute value for the difference. And yeah, so we just read those notes and then if you cannot figure it out, just let me know. Okay. I do have office hours, um, additional office hour on Saturdays from 1 p.m. So if you need any help, just please stop by on Saturday. So I would definitely gonna help you out with all of this. I know I just wrote something. I should give one example, which I did not. Um, okay, so any questions so far? Any questions? Another test. Just give me a few minutes, okay? Let me just stop that real quick. All right. Just yeah. Uh, another test will be on the exam. So I really yeah. So yes, please stay here for a few minutes. I know I'm running out of time, but I really I have to quickly go over that. We, we constant as well. It will be on the final exams. I'm sorry, we'll be on an exam 4. So um I really have to go over that question. It's very important. Yeah, it's like three and then add them up, minus ones total. I want to try something that we did, something that they give us. Yeah, this one. Yeah, I have to go over that one. It's similar to that on the exams. Okay, so this. All right, how many flight totals will the sample? It just this is degree of freedom, and gonna get 1386 something like that, right? It's apparently that we have so far. You can always 1386. Just take one plus plus one from that degree of freedom, right? And then it is assume what is an estimate is 95.11, something like that. It's just simply what we have. So if I make sure you're gonna remember those questions and not the other one, okay? And then the app test can be computed. The apps can be computed by taking the ratio between group over within groups. I would definitely gonna post it. I would definitely gonna post that when you compute the app test. You know, yeah, with between group over within groups. Okay, so we're gonna take all we have to take a bigger divided by the smaller. So the app is simply 242.63 over 91.11. Okay, so you have to do it on a calculator. I don't have time for that, so I know the answer was 2.55, something like this. Okay. And then now we need to compute the p-value based on the app test. Um, so it's not that bad on the calculators, but you have to be extremely careful when you look at the total degree of freedom. First that we need to take the calculators. Uh, Rush. I'm so sorry. Definitely gonna let you go soon. After we do this. So the app test was 2.55, and this one was like 5 degree freedom. The total was 1385. And let's see, we got 0.026. Oh, it says critical value. Um, it's not. It's basically not the. It's basically not a p-value, so it's kind of different from what we have so far. So yeah, so this is the p-value. Just making sure we got this, and then I will show you how to define a critical value quickly. Just give me a few minutes, okay? Just because the exam might have like two different parts. And if the question gives the p-value, asks you to find a p-value, so you have to do this, okay? And then, so this one is 1385. You should be able to get it, okay? And then the critical value is going to be the same thing, so the p-value first, just in case that you don't know on the exam, okay? And if you want to find a critical value, then we have to do the other way around. Is the F-test always be 112. We compare the multi means within like samples. Like we have four different sample for a single calculation, for a single population. So we need to compute the app. So this is what we have to do for the critical values. So we're gonna put on the the questions. I don't have time. Oh my goodness, where's the alpha? 5%. Yeah, the question was given alpha 5%, and then we just look at the 5 degree of freedom, and the total degree of freedom is 1385. You should be able to get it like 2.22. Okay, are we good? Yeah, you should make sure you're gonna we know this example. So this critical value. And the critical value that we found was 2.22. Yeah, 22. If the question asks you to find a p-value, just look for p-value. The question asks you to find a critical value, then you have to find a critical value of the app test. And that says 2.22. And 2.22 is basically less than the statistical value. When the statistical value was greater than the critical values, stay out of the null hypothesis, meaning that you can claim it, right? You just have to say yes. Um, since I'm gonna write this real quick. I'm running out of time since the F statistics uh equal to it just compared that 2.55 was greater than the critical values. We call FC. So that is 2.22. So we have to say yes to the claims, right? To the claim. Okay. So we finished that question. I think I have to go one more, but the weak constant will be on the exam. So it's the side test. All we have to do is just basically we look at the negative parts, look at the positive part, take the absolute value, add them up for all the negative, add them up for all the positive. We compare with the smaller sum. That's going to give you the critical values, and then you're going to compare that along the way. But that question was got it will be a little bit hard and tricky, which is so this one I will definitely gonna go over it, but I don't have time for that. We're gonna do this because the calculator does not give us like the range. So you have to take the absolute, you add up all the negative, you add up all the positive. So which one is smaller going to be the test statistics. Okay, so it's a I would definitely go over that if people just go to office hour on Saturday. So this is the bonus hours for those of you who really need help with, and then you can compute it quickly. Okay, we just add up 8.5 and all of this. Okay, and then the critical values is, and then yeah, this one will be very important. So we're gonna go over that. This will be on the exams on the office hours. Okay. Um, review on the office hour. Yeah, I would take that example and put it on the. I'm sorry, I'm gonna put it on the chapter summary, which I did not give out any example. I'm so sorry. But anyway, so um, what time is the office hour going to be 1 p.m. 1 p.m. Well, office hour. Okay. Yeah, I'm so sorry for like a little talking right there. So we spent like maybe 10 minutes on it and also another 20 minutes since we didn't have the final exam review. So I want to make sure that people understand the final exams. I might spend a little bit times on the data days, just talk about the final exams. Um, because the way Alex did was kind of different from the way that I usually teach my class. So it's sort of different. Um, so anyway, uh, Jasminer. Jasmine is here. Jazz is here. No. Malika. All you do is just have to say yes, and I will let you go quickly. Annie, Rachel, Selena, Hashan. Okay. Samina, Sarah. Sarah is here. No. Okay. Alexis. Gotcha. Um, Yi. Gotcha. Marlene. No. Jocelyn. Fulari. Nadir. Nico. Nadir is here. No. Tina. Oh, gotcha. Uh, okay. Tina. Got you. Ariana. Yeah, we have so many people absent today, so I have to go over like, every single person. Nico. Got you. Karen. Karen's here. Mitter. Amama. Lisa. Cheer. No. Cheer is here. Catherine. Chloe. Elkin. No. Yelly. No. The Damaris. William. Will is here. Gotcha. Uh, Lenny. Lenny's here. Okay. We have so many people was absent today, and like I said, that we have to go over this concept. Is very important on the exam. So if you guys can, please come to office hour on Saturday, which is tomorrow, and about 1 p.m. So I definitely gonna go over this is additional hours for us, and then I would definitely put the recording and do um the lecture review as well for the exam four. Okay. All right. So I'll see you guys next Tuesday for the data day. Have a good day. Take care.